So hopefully we don't throw a wrench into anything right now. We're trying to make things actually a little bit more realistic. But we're talking about yield in the chemical reaction. Now, what do we mean by yield, if anything? Well, think about it more in terms of, say, food, for example. When you get a recipe, it will tell you how many, in this case, lemon poppy seed muffins you can make, or in this case, it says servings, which is kind of a similar idea. How many people will feed? How much can you get out of it? I think that turnip souffle had some stars beside it. But when we're talking about a chemical reaction, what do we do? How do we work with that? Well, let's have a reaction. Now, you've seen reactions like this lots of times. We've done stoichiometry with them a lot. You've got a reaction, you've got your unknown, and here we're looking for a mass, and you've got your known substance and a known mass. So that's a mass-mass stoichiometry. If you were to go through and answer this question, and I encourage you to pause it and answer it just for extra practice, but if you did, awesome. If you didn't, here's what you would have, should have, could have done. Now you'll notice, of course, that we have all our 3 steps in stoichiometry, converting from the mass to the moles, going from moles of aluminum to moles of aluminum oxide, and then finishing up with mass of aluminum oxide. And we would get 163.4 grams. That is the mass that we can make. But what about all those things that could go wrong? Maybe different things happen. Some reactions just don't work. Maybe transferring from one container to the next container. Think about making cookies or pancakes or something. You never get the bowl completely clean. Now, in chemical reactions, of course, you don't end up eating any of the batter, so we don't have to worry about that. Okay, so the theoretical yield is the amount of product you could get if, big if, everything was perfect. But in life, chemistry, things are rarely perfect. No matter how good you are at doing the work, there are things that simply you can't control, and that takes away from that perfection. So the perfection thing is not what we're after. Well, then what's the point of stoichiometry? Well, we calculate, using stoichiometry, the amount of stuff that we should, in theory, be able to collect, or theoretically yield. And then the question really becomes, well, if you look at that as a stoichiometry question, those stoichiometry questions we've been doing now are our theoretical yield. So we're bringing in a new term, but we're doing the same thing. Actual yield, then, is, well, no big surprise, how much you actually get. Now, I want to back up for a second. The place where you're going to use actual yield and theoretical yield is when you're talking about going from a reactant to a product. You can do stoichiometry between 2 products, 2 reactants, product, reactant, reactant, product. When you're going from a reactant to a product, then you can call it a theoretical yield. We won't always do so, but that's when you would use the term. So theoretical is a calculated amount, actual yield is a measured amount. And the formula for determining what we know as the percentage yield is right here. Percent yield is the actual yield divided by theoretical yield times 100. Now before you kind of get another formula I have to remember, think about a test for a minute. When you get a test, sorry I didn't really show you very much of this one, did I? When you get a test, you'll notice that it tells you what it's out of. That's a pretty awful circle. It'll tell you what it's out of. Now that's the theoretical amount you could get. If everything went perfect, you could get 43. But let's say you actually get 38. What do you do with that when it comes back? Well, the first thing you do is you take your 38 that you got, what you actually got, divide it by the 43, which you could have got in theory, and you grab a calculator, and it turns out that's 0.8837, I think. Yeah, I figured it out earlier. 0.8837. But you don't say 0.8837, you say, oh, okay, well that's 88%, unless you're really generous with your rounding, and then in which case you might do something else. But 88%, what'd you do? Well, you multiplied by 100. So you took what you actually got over what you theoretically could have got, and then you took that number and you multiplied by 100. Hey, looks familiar, right? Yeah, percent yield. Now the only thing we're doing differently than a test is we're talking about amounts of chemical. How much we calculated we should have got, how much we measured we actually got, and turn that into a percentage. So, taking that reaction that we had earlier, and we actually calculated out this already, 163.4 63.4. What if we and then did notice we didn't have to do that experiment to get that number? All we have to do is a calculation. So let's say we did the experiment and we ended up with collecting 128.6 grams. That's our actual. Well, how do we know, get a percentage for that? Well, we take what we actually got divided by what we could have got, multiplied by 100, and that's 78.7%. That's all there is to it. Theoretical yield, actual yield, percent yield. Two of them are new terms for the same kind of idea, and another one is using percentages, again, to do something a little bit different, to kind of give us an idea of how good our reaction was, how good our work was. That's all there is to it. You can keep going.